Alright, now that you know a little bit about light and the light spectrum, Roy G. Biv, and you know that blue light has the shortest wavelength, so it packs a lot more energy, photons, and red has the longest wavelength. When we learned about blue shift and red shift, like I mentioned, objects coming closer to us in space is going to look blue because the light's going to get compressed more. It's going to have a shorter wavelength, so it's going to look blue. Objects going away from us are going to look red because the wavelengths are getting spread out. But for me knowing the prior knowledge to that and my observation and my inference, I'll draw a hypothesis is if the lightsaber blade is blue, it will have the highest temperature compared to the other colors. Now, we have a problem. You see this? We can only test one variable. An independent variable, we cannot test more than one variable. We have two different lightsabers and I'm trying to test colors. This blue lightsaber and this red lightsaber might not be the same strength. I might get the wrong readings, okay? Technically, I have to have the same identical lightsaber. So what I am going to do is I'm going to lay this blue one down and I have right here this little knob that when I turn, it changes the blade color. So I can change it from red to blue to white to green to purple, and I can measure each one. And my hypothesis still stands: when this lightsaber is blue, it's going to have the highest temperature. Okay? And so we're going to run an experiment. We'll turn this on. We're going to collect the data. We're going to analyze the data, and we're going to see if my hypothesis is correct or it's rejected. Okay? Alright, be right back. Alright, I'm back and now I have my USB temperature device that will measure the temperature of the lightsaber blade, depending if the colors, maybe they'll all be the same temperature, but my hypothesis is saying that the blue blade will be the highest or the higher temperature compared to the other blades. Now, with that being said, this thing measures temperature in Kelvin. That's a scientific temperature. Right? Some countries use Celsius, 0 to 100, with 0 being freezing. We use Fahrenheit scale. 32 degrees Fahrenheit is when water freezes for us, so we don't get much snow, so when it's 32 degrees, it's going to be around 32 degrees. And if we get lucky, then we might get some snow. You all know this. On a 90 or 100 degree day Fahrenheit, you know it's really hot. Okay? This is Kelvin scale. This one goes really high and this can go really low. When 0 degrees, and I said that wrong, 0 Kelvin, you don't say degrees. Celsius you say degrees, Fahrenheit you say degrees, but Kelvin you just say Kelvin. 0 Kelvin is the lowest anything can possibly be. Every single molecule is not moving at all. Even at 32 degrees Fahrenheit, when you have ice, the molecules are still moving, they're vibrating, they're still moving, they're just not moving very fast. But 0 Kelvin, nothing's moving. So this is going to measure in Kelvin because it goes really high, and we measure the sun in Kelvin and all that kind of stuff. We can transfer it over to Fahrenheit or Celsius if someone wants to know how really hot something is, but we're going to use the scientific. So we're going to turn this on, and we're going to measure the red blade, and we're going to see the temperature in Kelvin. Okay, now I'm not going to move it, I'm going to keep everything because we have to have a control. So what I'm going to do is, for my control, I'm going to turn this lightsaber blade to white. We're going to use white as a control just to see what the temperature is on that, so we can base things on that, okay? And then we'll go through all the other colors. The constants, the things that are going to stay the same is, I'm using only one lightsaber. This lightsaber stays the same. I'm staying in this room. I'm not going anywhere else. I'm not going to move it or anything like that. That might influence the temperature of the lightsaber. Okay? So I'm right here. See? Goes from red to pretty colors, huh? Alright, and there's white. And then we're going to test the white. Alright, and I have a reading in here. Okay, and we'll plug it in a minute. And you see it on your screen because I've already done it. Now, go from white, let's go to green. Now the lightsaber is green. We're going to test the temperature of the green. Alright, and you see the temperature Kelvin. Now we're going to turn this to purple. Alright, purple. I'm going to test this. Okay, you can see the readings. And now I'm going to change it to red because I want blue to be last. And then red again. So we started off. We do the test on that. Okay, and then now finally, we're going to turn it to blue. And here's the blue. And we're going to do the readings on that. Now, I haven't analyzed the data yet, so I don't know if this data supports my hypothesis or not. Now I have to go plug this in, read my data, and I'll get back and we'll see if it supports my hypothesis. And if it doesn't, it rejects it, then I'm going to form a new hypothesis. Alright, I'll be back. Okay, my data did not support my hypothesis. That does not mean that I did the experiment wrong. I did it correctly. I just have to rethink my hypothesis, and this time I'm going to pick purple as the color, and I'm going to redo the experiment. Just remember your 7 steps to the scientific method. I had to ask a question. I wondered why. I wondered, I made an inference. Okay? After I made observations. Then I came up with an idea and I said, from what my prior knowledge is about light, I believe that if the lightsaber blade is blue, it will have the highest temperature. I set up an experiment. I did all the experiment. I kept everything the same. I didn't use 2 different lightsabers. I used one, changing the color, keeping everything cool. I even had a control, which was the white color. And as you can tell, the white was very hot itself. Then I had constants. I didn't move around. I didn't measure some of them and then go in there and measure some in a different room or go outside or anything or use a different measuring tool. I kept all of it the same. Okay? And that's what you gotta do. You can only have one variable. If I would have had more than one variable, then I wouldn't have known if it was the actual color or the actual lightsaber if I would have used 2 different lightsabers. You can only test one variable. So your independent variable was the color of the blade. The dependent variable, it depends on what it is and it's going to be measurable, so it's going to be the temperature. Think about it like this statement. How long has it been since I had a haircut? Okay? Now the independent variable of that statement was going to be how many days has it been since I had a haircut. Okay, the dependent variable is how long is it compared to the days. They correlate. Most likely the longer I go without getting a haircut, the longer my hair will be. Okay, independent, dependent. Dependent is going to be something that's measurable. Okay, independent is what you're testing, and you only want to test one variable. Make sure you understand that if you're on a test and they have more than one variable going on and they're doing whatever, plants, and they're trying to use fertilizer and they have different soil in the plants, they can't do that. You're not going to know if the plant's growing because of the soil or because of the fertilizer. Pick one variable and test it first. Get your result and then you can try the other variable. Okay? Alright, I hope this kind of clears things up and I hope it helps you with your test. Thank you.
I'm intelligent and relevant to scientific method. Pushing to an A, got my head real steady. I'm doing it real big, this right here can be a hit. Designing and conducting all these experiments. I'm a whiz kid, put me to the test, it don't matter. Collecting and interpreting all these kinds of data. Asking most of the questions and giving real good suggestions. I'm always alert, no kind of depressions. Making observations and all these the inferences. Going Mr. Ray Way, you know who it is. It's the microphone beast. Can you understand my spit? In class, I'm developing hypotheses. They say I'm slow, sometimes they say I'm stupid. You must be out your mind, I'm just drawing these conclusions.